All right, we're dealing with homework 2 of Module 1, and this is dealing with inequalities. So it's chapter 2, dealing with inequalities. And when we're dealing with inequalities, we really focus in on this concept of, the greater than symbol, the less than symbol, and then the greater than or equal to symbol, and then the less than or equal to symbol. And I like to think of the inequalities are actually literally pointing in the direction in which they go. Like if this is greater, then it goes ahead and points to the right. If it's less, then it's pointing to the left. And that's kind of a neat way of thinking about it. And the difference between these two is that this is not equal to the number that we're indicating, and this is equal to the number that we're indicating. So when we're looking at this, we're going to go ahead and see, is there a question? Is there a question? All right. I'm just going to assume that there's no questions. Okay, no problem. All right, now I'm going to go ahead and do question number 1, where it says to graph the inequality. When I go ahead and graph the inequality, all right, I'm going to look at the number that's indicated. So I quickly see that it's 2. So it's x is greater than 2. That's how we say that. So we're going to go ahead and wherever the value is, I call it the value of indication. So that value is indicated. So I'm going to go ahead and put either a closed circle or an open circle at that value. So when I go ahead and see that it is an open or no line, it's going to be an open circle at that value. And then since it's pointing to the left or right, I'm going to go ahead and put my arrow going to the right. All right, and that's how simple this is. So I'm going to go ahead and do that electronically. I'm going to put that here. All right, hopefully it's, let me clear that. Doesn't look like it's exactly on the 2. There we go. And then I'm going to put an arrow going this direction. And that's how we go ahead and do that. All right, now it says interval notation. What is interval notation? So interval notation is a way of describing this graph through parentheses or brackets. So if it's the way that this works, if this is a parentheses, all right, and it's pointing to the right, it's going to be open parenthesis at the value of the variable, or the number. So I'm going to put number here, whatever that number is, comma, and then I'm going to put infinity, also parenthesis. For this one right here, it's going to go negative infinity, comma, number. All right, notice how both of them are open for these two guys right here. All right, now for interval notation for the equal to sign, it's going to be the same exact thing, except for you're going to have a bracket instead of a parenthesis at the number. And it's going to go infinity. And the infinity signs always have parentheses, by the way, because you can never stop at that, any number. So this one is going to be negative infinity going to the number and with a bracket. So that's for this one, and that's for this one, okay? So that helps you with understanding how interval notation works. So when we're dealing with this guy, this is going to take on the property of this. So I'm going to put a parenthesis, the number, and then an infinity sign, parentheses. So I'm going to follow what I just wrote down here. Wherever you see the hashtag, it's where you put the number. So that's where we're going to give the answer for that. All right. And that's what I just wrote down here. Okay. So now when we're looking at the second part of this, okay, so here we have the answer for that one, which is I already gave. And then we're looking at this one that we're going to be looking at the value of indication is 4. And it's going to be a closed circle this time. And it's going to the left. So that's what we're looking for that one. So I'm going to go ahead and put a closed circle at the value 4. And then I'm going to go ahead and draw my line that's going to be going to the left. okay? And then my interval notation is going to be, since it's this one, all right, it's equal to, it's this symbol right here, I'm following this pattern, I'm going to put negative infinity, the number, and then bracket. All right, notice it's this one. These are pretty powerful. I'm giving you these for purpose. You probably put these in your notes to indicate these. Because once you have those symbols, and that's what we were looking at, because the value was x is less than or equal to 4, then we know that this is going to be following in this structure. And that's why I go ahead and put it as such. Okay, so that's a good process. And you'll see the answer is exactly that. Okay, with a bracket and everything else. And here's the answer that I've given you. All right, my answer here is the same thing as here. All right, so that is graphing. And now I'm going to speed this up a little bit for this one. Now, right here for number 2, this is question number 1. Question number 2. This one has it where the variable is on the right side. Now, I don't like it when the variable is on the right side. So what I can do is literally think about this on a carousel. I can just spin this around. And then while I'm spinning around, the inequality will continue to be the large side with the number and the smaller, or the pointer is pointing at the x. So I'm going to continue to point at the x. And then I have -3 over here. Okay, so I spin it around. All right, now I go back to what we do up here, because it's otherwise going to be backwards. Because if you look at it the way it is right here, it should be pointing to the right, but it doesn't. It's actually literally supposed to be pointing to the left, and that's the problem. So I want you to set it up properly. Although you can graph it this way, this is more, I guess, more structured. Go ahead and graph it from here. So value of indication, -3. It's pointing to the left, and it's going to be an open circle because it's not equal to it. All right, and that is what we get for that one. All right, at -3. Now, the inequality, or the interval notation, it's going to be pointing to the right, or left, excuse me. So I'm going to be this one right here because it is no equal value. So it's going to be negative infinity. And the value of indication is -3 with a parenthesis. All right, that's going to give us that answer. All right, now when we're dealing with this one right here, this is what we call a compound inequality when you have this particular structure. Now, whenever it's two less than symbols like this, it's going to be a compound inequality that's bouncing into each other. And because it's a value that's just a less than symbol, it's going to be an open circle. And since this is a equal, then it's going to be a closed circle. Now, notice how I put these values over exactly these two numbers, because that is exactly what we're going to put as far as our answer is concerned. And that is making sure also recognize that -2 is less than -1. So that is how we graph it, and that would be the answer that we're looking for this one. All right, see that? That's exactly what I have here. Okay. Now, when we put the interval notation for this, it's going to be following sort of the same thing as this, except we not going to have any infinity signs, because now it's going to be a less than symbol at -2. And then -1 is going to have a bracket. And that's the answer for that one. All right. So now we're looking at solving inequalities. So we're graphing them before, now we're going to solve them and then graph them. So for question number 3, we're going to take and solve it like we do a typical equation. Isolate the variable. The only difference is that if we're going ahead and dividing or multiplying by a negative, we must switch the inequality symbol. That's the difference. So, and we can see what's going to happen here is we're going to have to switch the inequality on this one because the leading coefficient to the variable is negative. So we're going to go ahead and subtract 9 from both sides. That does not interfere or disturb the inequality symbol, by the way. But then when we divide by -3, anytime we divide or multiply by a negative value, this is going to prompt us to go ahead and switch the inequality symbol. Now, I'm almost falling off the page. I'll do that. Okay. And then 9 divided by -3 is -3. All right. Now notice the inequality symbol. It used to be a greater than symbol. Now it's a less than symbol. All right. So that is a big deal. Now graphing it, we would go ahead and notice it's pointing to the left. So we're going to put an arrow to the left. We're going to put an closed circle at the value of indication. And then for the interval notation, we would go ahead and put -infinity to -3 closed bracket. And that is the answer that we're looking for here. All right, I got both answers completely correct. All right, so that's how we do those kinds of problems. Now be sure to remember that you switch the inequality if you're dividing or multiplying by a negative, not when you're adding or subtracting. All right, so now we look at number 4. It looks like it's getting busier, right? So we're going to have to do a little bit more manipulation. The structure doesn't change. It's just a little bit more we have to do. So we're going to do that. I'm giving you plenty of examples here so you can model after them. And this is your homework. So your homework is going to be, if you're following along with me right now, you're able to complete your homework with me. Now, this is recorded, so you can go ahead and take notes a little later if you so desire. Just watch along with what I'm doing. So the first thing I see is groupings. So I'm going to go ahead and do the distributive property. So I'm going to go ahead and do the distributive property. So -4 times -x is going to be +4x. -4 times 2 is -8. And then I'm copying the -25, and then 3 times 5 is 15. And then 3 times -3 is -9. And then I have -5x. Now I combine like terms. So I have 4x, and then I have a -8 added to a -25. Now both of them negative, so you're going to continue to go negative. So it's going to be -33. And then the 15x subtracting 5x gives us 10x. Now I combined like terms on either side. I'm reducing down the number of terms we have. It used to have 6 terms, now we have 4 terms. Now we need to bring the variables together. So what I'm going to do is, watch this, I'm going to bring this over because I want to keep my variable on the left side. As I told you before, we like the variable on the left side. So I'm going to go ahead and subtract 10x from 4x's and get -6x's. And then I'm going to go ahead and add 33 to -9. Now when we do so I'm adding 33 to -9, I'm going to go ahead and subtract 9 from 33 and get 24. Now I'm going to go ahead and divide by -6. And because I'm dividing by a negative, the inequality will switch, and I'm going to go ahead and divide 24 by -6 and get -4. Now, to graph it, I'm going to simply just go at the value of -4, the value of indication, and put an open circle and put an arrow pointing to the left. And then I'm going to go ahead and say, well, I know I'm going to go from -infinity then all the way up to -4 and put an open parenthesis because it's not equal to it. So let's take a look at our answer. It looks like we have the right answer there. And then we have the right inequality, or interval notation, excuse me. Okay. So that, although it's busier, it's doable, if you just keep calm and just follow through the procedures of bringing like terms together. Now, number 5 has it where it wants you to go ahead and write an interval notation for that. Well, that kind of models this equation we did over here for number 2. All right, number 2 is like that. So we're looking for something that looks kind of like this. All right, so we're going to go ahead and do that. We're going to go ahead and see that it's a closed circle at -24. And we're going to put a comma and then put -20. And then it's an open circle, so we're going to put a parenthesis. And that is the answer we're looking for. All right, that's pretty straightforward. It just depends on whether or not you know what these different symbolizations mean. All right. Now, some of you probably may be looking for notes regarding that kind of stuff. If you are, then at the end of this, I'll go ahead and show you where my PowerPoints will lead you to also understanding this kind of stuff. All right, number 6. It says write the following interval notation. All right, write the following in interval notation. Now, this is what we call set builder notation when it's written like this. So all we're asking really is to write this into interval notation, and that since it's like this, okay, we're going to go ahead and follow that model I gave you earlier, but it says that x is greater than all these values. So we're going to go ahead and put open parenthesis at -22. And then since it's pointing to the right, I'm going to go ahead and put a positive infinity sign with a parenthesis, and I'm done. That is the answer we're looking for. All right, now number 7. Now, number 7 has fractions in it, and a lot of students do not like fractions. They're very afraid of fractions, it seems. My best advice is to kill fractions, as we did in lesson 1. All right. Now, the way we're going to kill it, 3 goes into 27. So 27 can't go into 3, so obviously, but 27 can go into itself. So we're going to multiply both sides by 27. Three goes into 27 9 times. 9 times 9 is 81. Now hit reset. 27 times b is 27b. And then we go ahead. Hold on. 32 is hold on. Oh, thank you. You're beautiful. I love you. I love students. They are so beautiful. Okay, that is true. That's called a transcription error. All right, now we have that. Okay. You know, Amy, you're a beautiful person. Okay. Now we're going to go ahead and subtract 81 from both sides and then divide it by 27. Now, it doesn't mean you have to go ahead and do it all by hand. I mean, you can simply just do it like this, like 32, subtract, all right, I hope you can read it. Yeah, 32, subtract 81, all right, because that's what we need to do is get that 81 over to the other side. And then we're going to go ahead and divide it by 27. Now, notice how it doesn't go into it, right? So what you could do is hit this button right here where it gives you fraction to decimal, decimal to, decimal to fraction, fraction to decimal. So we can hit second, that, enter, and this I love this calculator. This calculator is a piece of junk, sorry, but I might use another one in a second. But anyway, we had 32 divided by, no, not 32, excuse me. I gotta get this. It's -49 divided by 27. By the way, I'm double checking my operations. But I hit second FD, and it does this to us. I want to share this with you. Okay. I need a lot of light for this thing not to go dead on me. But anyway, you can see that this does this. So it's -1, all right, and then it's 22 over 27, okay? Now, the thing is that it's not like it's going to make much of a difference. It's just changing it. So what we're going to do is leave it as such, and watch this, all right? You have the -49 over the 27 because it doesn't go into it. So when we do the 27, all right, and we get -49, and we divide both sides by this, and we get this, all right, this doesn't go into it if this happens. It doesn't go into it, and so we can leave it as an improper fraction. And I'd rather leave it as an improper fraction than a mixed number like that, okay? So, but we got this, right? And when we're looking at putting it in interval notation, all right, because it asks us to write an interval notation, it does say that b is less than it, and that gives us the inequality of negative, or not, well, interval notation of negative infinity, comma, -49 over 27. All right, so that gives us our answer there. So that's dealing with fractions, okay? So I know sometimes the pain, and we can use our calculators to help us with that. Now, that's using that particular calculator. Now, this calculator will be particularly better. This is the graphing calculator, and that would be more advisable because it'll do different things that won't do. But I'll use that instead since this one's having a problem. This calculator seems to go out on me a lot. Okay, so anyway, let's go ahead and do number 8. Now, 7x plus 6 over -5. All right. We have that. Now, since we need to undo this first because we can't deal with the x and with the, the 7 and the 6 or whatever, I need to go ahead and multiply by -5 to both sides. Well, wait a second. I just multiplied by a negative. Anytime I multiply by a negative, I got to switch my inequality sign at the same time. All right. So I just did that. Now I'm going to go ahead and subtract 6 from both sides. And then divide both sides by 7. So I'm going to get x is greater than or equal to negative, and 16 over 7 also is one of those situations that the fraction doesn't reduce. All right. So I'm going to go ahead and give you that as an answer. And then what it's greater than, so it's going to be equal to, so I'm going to go ahead and put a bracket with -16 over 7, comma, positive infinity, and then put open parenthesis. Okay. Oh, that's great. They didn't even ask us for interval notation. So I did it anyway. I gave you this answer and that answer. All right. Anyway, I didn't read the instructions, that means. All right. I would make sure to double check my reading before I write my answer. Okay, that's what that indicates. All right. Now, number 9. So number -2 all right, it's good. -2 times this. So I'm going to do distributive property for this. So -2 times -15 is positive 30. -2 times 11 is -22 x. And then I have -10. All right, I have that. Okay, now I'm going to go ahead and bring my like terms together, keeping my variable, all right, onto the left side, I'm going to bring the 6 over, make it, added to that. Okay, adding 6 to that, I'm going to get 16x. That's negative still. And then I'm going to go ahead and subtract 30 from both sides and get negative 40. All right, and then I'm going to have to divide by negative 16. By dividing by negative 16, that makes me have to switch the inequality sign. And while I'm switching the inequality sign, I'm going to also reduce this down because 4 can go into both those values. Okay, I think, yeah, I think it's 4. No, it's 8. 8 can go into both those values. Sorry. All right, so now let's go ahead and do that. So that's going to be positive, and then 8 goes into 40. 8 goes into 16. So I have my answer of 5/2. Now, reading the instructions, it says write or solve and write in interval notation. It wants us back to interval notation. So I'm going to go ahead, since it's pointing to the right, I'm going to go ahead and put parentheses, 5/2, and then put a infinity sign. Okay, and there's our answer. All right, so that's number 9. Okay. We have a couple more of these left, and then we're done. All right, now, a local salesman receives a base salary of $750 monthly. He also receives a commission of 8% on sales over $1,850. How much would he have to sell in a month if he needed to have a monthly income of $1,800, $1,800? He would need to sell blank to reach his needed monthly income needs. All right. So now let's go ahead, and it says that his base salary, all right, local salesman, is $750. Now he gets 8%, so it's 0.8, not 80%, but 0.08% of his commission, which we don't know what it is, or what the sales amount. And then he wants to be over 18. Oh, wait a second. Okay, so wait a second. This is not right. Okay, I gotta do this. Not right. All right, it's anything over $1,850. So you're gonna go ahead and do X, and then this is a sales, and you got to go ahead and minus the 1850 from it. All right, because we don't want to include that in the percentage. Okay, so you get $750 plus 8%, anything over 1850. So subtracting 1850 from the sales, all right, would allow us to compute how much money he gets for the 8% of the sales. So that's important. Now it wants to know how much would he need to sell in order to get $1,800 for that sale, or for that commission, or the commission plus his salary. So now we got this. We just take our calculators and then just do, well, we don't have to really do our calculators for 0.08 times X, but we do need to do it for the 1850. So 1850, all right, times 0.08 gives us 148. Plus 750. All right, so now we have that. So now we're going to go ahead and take the 750 minus the 148. And that gives us 602. And then we're going to take the 1800 and subtract the 602. So we can get this out of here, right? So we need to get that away from that. Okay. And then we're going to go ahead and take and divide that. All right, all I'm doing is copying that. And then we're going to take that value and divide it by the 0.08. So his sales would have to be greater than 1,000, no, excuse me, 14,975. So that's why it's important to have a graphing calculator. Because look at this graphing calculator. Look how beautiful that is. I can actually see it. It's easier to read than this crap I was doing to you before. So I encourage you to grab this. Okay, but anyway. So that should be our answer, and we see that it is $14,975, exactly what we have. So we got our answer. All right. So word problems are pretty challenging, and I would understand some of your frustration with word problems, but this would be a great example to use for number 10, of course. Okay. You should be able to model after this and be able to do your own question. All right. Now, let's do number 11. All right. A lot easier than the one we just did. All right. So this one, we go ahead and add 9 to both sides. Okay. If we add 9 to both sides, what are we going to get? All right. 9 added that would give us what? 8. Yeah, 8. Negative, that is. All right. Dividing both sides by negative 8. That switches the inequality sign. And that gives us positive 1. So now, what is it at? Oh, it's just asking us to graph it. Here, I've already demonstrated enough on graphing. So there's that, and there's the answer for interval notation. All right. So pretty straightforward. Number 12. We have a compound inequality where we have to solve it. What we do to the inside, we do to the outside. I'm going to show you a couple of things going on here. This one's a good question right here for us to go over. We're going to go ahead and first subtract 1 from both sides as well as the middle. So subtracting 1 from everything. All right. So I'm going to get 6. And then I'm going to go ahead and get this. Excuse me. Now I'm going to go ahead and divide everything by negative 2. When I divide everything by negative 2, I got to switch the inequalities at the same exact time. So this is going to give us negative 3. And then watch this, the inequality signs are going to switch at the same exact time. But now when we look at this, right, negative 4 is less than negative 3. So we got to switch this. You know that merry-go-round thing I was talking about earlier? We got to switch everything around so that way it's written properly. So we're going to get this instead. So that's why I liked this question a lot. It's important that I went over this with you. Now, as far as the interval notation, then it's just going to be an open parenthesis at negative 4, and then for graphing it, and then it's going to be a bracket. And it's kind of funny when I write it like this, okay, because then it's like rather than writing it with an open circle, closed circle, but this would be an open circle, this would be a closed circle, all right? This gives us an interval notation at the same exact time. So watch the answer. Here we have that is our answer. See, open circle, closed circle. And then you have also your interval notation, which is the same thing. All right, number 13. Now, when I have this one, I'm going to go ahead and do the distributive property. And then, of course, 143. Then I'm going to go ahead and subtract 143 from both sides. And I can just go ahead and just do that real quick. All right, that's going to give me this. All right, and then I'm going to go ahead and divide both sides by negative 13. That's going to switch the inequality. Now that's not going to go into it, so I'm going to just make sure that I have it in most reduced form, but this is going to give us positive. All right. Now what I did do is just check it real quick, but what I do like about checking real quick, it tells me it's about 11.7. All right, so I know that's about 11.7 when I switch this inequality, because remember, I have to put it from the smallest to the least, and this is going to be an important factor when I take and do 151. Okay, this is going to be positive, and this is going to be negative, so this one's going to be less right here. All right, that's going to be that. Now falling off the page again. Okay, so now I'm going to go ahead and switch it around. So I'm going to go ahead and switch the values. I'm double checking that 151 divided by 13, that doesn't go either. Just double checking, right? Because I don't feel like doing the math. I just go ahead and just check it on my calculator. It doesn't go, so I'm going to leave it as such. But I'm going to switch the inequality signs and make sure that I'm in the proper form. All right, and there's our answer. All right. So now there is a sign. Let me see if I messed up the sign. There is a sign issue, isn't there? So I have a sign issue. Okay, so that should be positive. So that's positive. I do have a sign issue. All right, so I'm making sure I correct my sign issue. All right, so that should have been negative when I wrote it. So now I do have the right answer, just one error on the sides. So, okay, now number 14. So we have 2 less than 1x. We don't really need to write the 1, but they just do. So you go ahead and subtract 9 from both sides, or all sides, or the middle and everything. I'm just going to put x. And then that is our answer. Once we're done with that, all right, we just subtract 9 from everything, and that gives our answer. All right. Now, of course, that's not in interval notation, but that's the same answer. And the last and final one, number 15. We're going to go ahead and add or subtract 9 from both sides, or everything. And then we're going to multiply everything by 7. And what they want in interval notation, I'll write in interval notation. And there's our answer. All right, so I did 15 questions for lesson module 1, homework 2. All right, and that concludes this video on that homework.